Hello, and welcome to this special edition of CU Science Update. I'm Joey Maestas. This is our third and final show in a series of special editions we devoted to participants from CU's 62nd Annual Conference on World Affairs, which took place the first week in April 2010. In this edition, we interviewed Seth Shostak, an astronomer, author, lecturer, and frequent guest on numerous television and radio programs. Shostak is also keenly engaged in the search for extraterrestrial intelligence at the SETI Institute in California's Silicon Valley. He has written hundreds of popular articles on astronomy, and his book, Confessions of an Alien Hunter, hit the store shelves in 2009. Dr. Shostak took time to talk with CU Science Update's Ina Dalmurray in our studio.
You know, I wouldn't do it if I didn't think there was some reasonable hope that within my lifetime we're going to pick up that signal that tells us what we want to know.
This little speck of metal is picking up signals that might be coming from hundreds of trillions of miles. It's like a tin can with a string that runs up 100 trillion miles. We could hear a cell phone on Jupiter if there were any. That's how sensitive this system is.
All right, well, welcome, Seth, and let's talk about aliens.
Okay.
Yeah. Are there any strong candidates out there?
Well, we haven't found any life, beyond Earth. Whether you're talking about little gray guys with big eyeballs, right, or whether you're talking about microbes, or whether you're even talking about dead microbes, we don't have any conclusive evidence of any life beyond Earth. But there's a lot of reason to think they're out there. We just haven't found them yet.
And what are one of those reasons, or a few of those reasons, why there might be life out there?
Well, to begin with, there's the fact that our world seems somewhat mediocre. Now, I'm not just talking about your guest today. I'm talking about the Earth, right? In the sense that what you find on the Earth, you probably find lots of other places. The whole universe is made out of the same stuff you learned about in junior high school, same 92 elements. And we know that, all right? So, how special are we? Well, we don't know that. We've never found another world like the Earth. But we found a lot of planets around other stars, and in the last 3, 4, 5 years, we've been able to look at the data and say, the number of planets just in our galaxy is probably on the order of 1 trillion. It's a million. Mm-hmm. That's a very large number, and maybe most of those planets aren't very appealing, maybe like Mercury or Neptune or something, but some of them by chance will be okay. So, just on the basis of that sort of argument, you think, look, if we're the only kids on the block, then there's something miraculous that's going on here, and it's difficult to believe that.
Yeah. And so how does it work then with finding these signals or messages? Like how does that process work in itself? Well,
the idea is if you think that there might be some, not only life out there, but some life that's as clever as the average, resident of Colorado, for example, then, you could think, all right, I'll do what they do on TV and I'll just go there and find them, but we can't do that. We don't have rockets that are nearly fast enough to do that. You could wait for them to land. A lot of people think they have landed, but most scientists are somewhat skeptical. Or you can do what we do, which is to try and find them at home by using big antennas, for example, and trying to eavesdrop on television broadcasts or radio signals they're deliberately sending our way. And that makes sense. You can, run the numbers, and it turns out it's not very hard to send signals from one star system to another. So that's sort of what we do. We're trying to eavesdrop on the aliens.
But do we also send out messages?
Well, we do, but not really deliberately. Yeah, there haven't been too many cases where scientists have said, we're going to broadcast to ET. It's happened occasionally. There was a very famous broadcast in 1974 from a big antenna down in the Caribbean, in Puerto Rico, at the Arecibo telescope. And they, for 3 minutes, they broadcast a very strong signal, but, it was only 3 minutes. What are the chances they'll be listening at the right time to pick it out? And it was also aimed at a ball of stars that's, 25,000 light years away. So it's going to take a while to get there. In general, we do not broadcast. We leave that to the television networks. We leave that to the radars down at the airport and so forth. So we've been broadcasting in a way, but usually not deliberately.
Okay, so it's just our existence.
Our leakage, as they call it.
Yeah. Okay, and so I guess again, the signals that we are looking for you're looking for when you're searching, right? What are these proofs, I guess, I'm trying to get to?
Yeah, what kind of signals would you look for to say, oh, that's really ET, and it's not just a quasar or a pulsar or something natural? Well, what we do is it's not a matter of what's the message, because our equipment might not be able to pick up the message. We're not looking for, the Fibonacci series or, some prime numbers, whatever they use in sci-fi films. They use that a lot. All we're doing is we're looking for a signal that's localized in the spectrum, which is to say it's at one spot on the dial, just like the local top 40 station. It's at one spot on the dial. If we find a signal that's localized like that in frequency, then we can say, well, that's not the kind of signal that nature makes. That must be somebody with a transmitter. You know, we may have no idea what they're saying, but at least we know they're clever enough to build a transmitter. So that's what we do.
And how long have we been doing this?
Well, the idea, of course, for looking for aliens, I mean, that idea is actually pretty old. In the middle of the 19th century, there were people in Europe who were saying, man, we should use big gas lanterns and mirrors and signal our buddies on Mars and stuff like that. So, you know, the idea is kind of old. But the modern incarnation of this idea is 50 years old in April of this year, which is now. So it's almost exactly to the day, 50 years ago, that the first search, where a guy in West Virginia took an antenna pointed at some nearby stars trying to hear something from the aliens, took place. So 50 years.
Happy birthday.
Yeah. Yeah. It wasn't I, but...
No, well... what would you say is perhaps in your career, like a breakthrough in these searches, or has there been one?
Well, the big breakthrough, of course, would be finding the signal. That would tell us that, hey, there's somebody out there. That hasn't happened yet. I honestly think it will happen in the next 24 years, but I could be wrong. I bet everybody a cup of coffee on that. No more than that.
The next 2,000 years?
2,000 years.
2,000 years.
2,000 years. 2,000 years, you know, it's a little less interesting for me.
Yeah.
You know, the funding may go away by then. The next 24 years, and the reason for that is there is a sort of a slow breakthrough taking place in this field, and that is the improvement in the equipment. It turns out that the march of technology means that every 18 months, the amount of compute power you can buy for $1 doubles. This is just an economic law of the Silicon Valley, and it has to do with computers and selling you computers. But it also has this sort of other benefit that it's speeding up our search for ET. And so in the next 24 years, we'll look at 1,000 times as many star systems as we have so far in the first 50 years. So all that means is that, look, if they're out there, there's a good chance we'll stumble across them in the next 24 years.
How many stars then do we sort of have, can we search for right now?
Well, I mean, there are a lot of stars out there.
I guess in comparison.
Yeah, well, we usually look in our own galaxy because after all, if you know, it's sort of like looking for big animals. If you can't find any on your own continent, you know, there are none here in North America, then maybe there aren't any anywhere. But so we start in our own galaxy, and the number of stars in our own galaxy is a few hundred billion. Okay, but we actually start nearby. We look at the nearest star, and then the next nearest star, and then so forth. Just sort of work your way out. It's sort of like if you were looking for rare foliage or rare flowers or something, you might start in your backyard and then work out to the neighbor's backyard and then just work your way out because it's easier to do that. And if you find something, it's closer to you, so you can, you know, study it more carefully. So we work our way out. And so the number of stars that you could look at in our galaxy is hundreds of billions. You could, in principle.
Yeah. Let's say that we heard a signal tomorrow. What would be the approach?
You mean what happens?
Yeah, what happens next?
What happens? Well, yeah, I mean, we do find signals all the time. I have to tell you that. I mean, I sit there in front of the displays, and you can see that you're getting a new signal every 10 seconds. Finding signals is not a big deal because there are lots of signals. The trouble is, they're us. They're not the aliens, right? It's, as I say, the radar down at the local airport, or it's a telecommunications satellite wheeling overhead. You have to sort all those out and get rid of all those because that's not what you're interested in. You're interested in extraterrestrial intelligence. But if we found one, you know, you wouldn't jump out of your seat and yell Eureka the way they do in the movies because, you know, it might be interference, it might be something wrong with your equipment, it might be a Colorado University undergraduate prank, you don't know. So you have to check all that out, and that would take 3, 4, 5, 6 days. But in all that time, the media are going crazy because there's no secrecy in this project. So they've heard about it. You guys are following an interesting signal, and they start writing about it. So the public is going to be thinking you've already found ET, even though you haven't confirmed it. It'll take about a week. And then, will people go nuts? I don't think so, because this signal's coming from hundreds, maybe thousands of light years away. There's no danger.
Right. That being said, no danger. So should we be afraid of first contact, or, you know, well, tapping into a little different direction?
Yeah. Well, there are people who see danger in this project. The only danger I can foresee in terms of listening, I mean, really, you know, somebody is watching this broadcast. Well, that's not dangerous to you. You don't know, or you're not dangerous to them is really the point, right? They can listen to us without fear that we're going to jump into their homes and give them a hard time, right? That we don't know that they're watching this or listening to this. Okay, so in the same way, if we pick up a signal from ET, he doesn't know that we're listening, so there's no danger in that. if we can understand any message, then it might be from a very advanced society. Now suddenly there's all this information, and maybe that might be dangerous in some sense. Now, you know, you jump 10,000 years into the future because they give you all this information. That might be disruptive in some sense. That's sociology. There are other people who worry about the fact that if we broadcast, that we might just, you know, you don't know what's out there, and maybe they're hostile, and they'll just launch their rockets and come down here and destroy the Earth, which will ruin your whole day. That could be, but I don't worry about it. If you're really going to worry about that, then you better shut down the broadcast companies and the radars down at the local airport, if you really want to do that. And also, by the way, turn out all the lights on the street lamps at night. Doesn't sound like a good idea.
No, sounds dangerous too.
Much more so.
Yeah, exactly. I guess, should we, do you think we will, is it possible that we will get contact, I mean, actual physical contact from on our planet?
Now, well, that would be more interesting, of course.
Yeah.
That's the way it always happens on TV and in the movies, right?
Of course, yeah.
You don't just hear from the aliens, you meet them.
Yeah.
Right, and sometimes they're friendly, but usually they're not, because it's really a better story if they're not friendly. But that's very difficult to do, because to travel between the stars, the distances are truly enormous. Our fastest rockets go 7 or 8 miles a second, okay? But to go to the nearest star, that sounds pretty fast, but to go at that speed to a nearby star, even the nearest other star, where Pandora is supposedly, right? Yeah, it takes more than 100,000 years. That's a long time to sit in a coach seat. So you're probably not going to do it. Now, if you can build faster rockets, and undoubtedly will do that, but it's unclear whether you can ever build a rocket fast enough to make it feasible for us to go to the stars. Then maybe the aliens can't do it either. It doesn't violate physics, but the distances are enormous, and consequently the amount of energy it would take to go from one place to another in any reasonable length of time. It sounds very hard. At some point, maybe you invent, you know, machine intelligence, and for machines, maybe they don't care that it takes a long time.
Yeah. Okay. Let's say that we do find a signal, and it's, you know, we're all. What do you think that would do for our society, you know, as a whole, with, you know, religions involved, and, you know, that is sort of pressing the mind into different areas from what we're used to.
Yeah, it's true. And a lot of people think that if we were to find a signal, that the government might cover it up because the public couldn't handle the news and they'd start rioting in the streets. I'd like to see that, but, you know, not going to happen. I mean, we've already run this experiment, right? In 1900, reputable astronomers were saying there's this vast hydraulic civilization on the red planet just 32 million miles away, right? On Mars, there were these canal-digging, crazed Martians. Nobody cared. I mean, if you were a fishmonger, you just monged your fish. I mean, nobody cared. It was all okay, right? So if they were to hear that there's a signal coming from very far away, the idea that they would suddenly, you know, all heck would break loose and civil disobedience and people in the streets, and that's just not the case. I think that what would really happen is that you would then spend some money, build a very much bigger instrument, try and understand what they're saying. How would it change us in the long term? It's hard to say. If you could understand anything they're telling you, then maybe you learn all sorts of nifty stuff, because they're going to be more advanced than we are. Otherwise, we don't hear them, right? So, you know, maybe they could say, oh, here's all of physics, and here's the cure for death, and here, whatever, you know, all this stuff, and that might change your life a little bit, okay? But I think that the real effect isn't any of that, because I'm not sure any of that would happen. It's just to know that what's happened here on Earth is not a miracle, that this has happened many, many times in many, many places. You're just another duck in the row, and that sounds a little discouraging, but heck, at least you know there are other ducks.
Well, I think it's going to happen. I think it may take a few decades yet, but it isn't to me, it's not a question of waiting centuries. I really think it's within sight.
You can learn more about our search for life elsewhere on Dr. Shostak's science radio show, Are We Alone?, with his co-host Molly Bentley at radio.seti.org. That's it for now. Join us again next time as we continue to explore new and exciting worlds in science and technology here at CU Boulder.